We'd like to welcome Milo Schield from Augsburg College up in Minneapolis, Minnesota, who will be presenting his presentation, Big Data Creates Beguiling Coincidences.
A coincidence is a big topic in the everyday media, but the idea appears more often than the word. Consider the phrase, too unlikely to be due to chance. This phrase claims the absence of coincidence and is used to argue for causation. So what is coincidence? Are these similarities just a coincidence? Coincidence involves an unlikely but meaningful conjunction. My thesis is that coincidence is much more common than expected. To show this to students, consider flipping fair coins and looking for a run of hits. Look at cell B4. It has the RAND between function with limits of 0 and 1. Cells with a 1 are colored in red to indicate a head. Run is a series of adjacent red cells. The number in column A is the length of the longest run in that row. The first row has the longest run of 3, 1 chance in 8. The second row has the longest run of 4, 1 chance in 16. The bottom row has the longest run of 5, 1 chance in 32. Now, is that coincidence? Consider a big data spreadsheet. This spreadsheet shows around 1,200 flips of a coin. Students enjoy pressing F9 and seeing if they can get a bigger number. The longest run in this round was 10 heads. Very unlikely, but the students are getting that or longer almost every time. Now consider a more unlikely event, tossing grains of rice onto small squares with 1 chance in 10 of landing in a given square. Look at cell A3. The function is the RAND between 0 and 9. 1 chance in 10 of getting a 9. A 9 is a sign of a grain of rice. Colored in red, a cluster is a group of red-colored cells that touch. The top row, 2 cells touching, 1 chance in 100. 3 cells touching, 1 chance in 1,000. How is this just coincidence? Let's look at a big data spreadsheet. This spreadsheet has more than 800 cells. We've got 3 cells touching, 1 in 1,000. 4 touching, 1 in 10,000. 5 touching, 1 in 100,000. That was just a coincidence? Well, not if it happens almost every time. Download these worksheets and let your students explore coincidence. Students quickly learn that runs and clusters are much more likely than expected. Getting a run of 10 heads is like a 1,000-year flood every year. 6 grains of rice touching is like having a 1,000,000-year flood every year. Now this is pure coincidence, pure chance, but it's repeatable. Now students are prepared for the big questions. Why is the unlikely so common? How can a coincidence be repeatable? Here are 2 reasons. First, the explanation. The question is ambiguous. There are really 2 questions with different answers. Are we asking the chance here or somewhere? The chance before or the chance after? Consider a run of 2 heads. What's the chance of that configuration repeating itself at the same place in the next try? 1 chance in 256. What's the chance of that configuration repeating itself anywhere in the next 256 flips? Close to 50%. The second reason is the law of large numbers. The unlikely is almost certain given enough tries. And compression. By overlapping things, we compress a lot of independent trials into a smaller space. Look at the flips of 10 coins. It's almost the same as flipping 24 coins, 8 sets of 3. A run of 3 heads is expected in 8 sets of 3. A run of 3 heads is generally found somewhere in flipping 10 coins. In conclusion, students must see that coincidence is much more likely, much more common than expected. This may be due to an ambiguity. It may involve the law of very large numbers. And most importantly, it may still be a sign of causation. Thank you.
And we'd like to thank Milo for his presentation this afternoon. Thank you very much.
Thank you. Please stand by.